Okay, let's look at another problem where we are asked to solve for one more thing. After getting the rate law with all of the orders for each reactant and the rate constant, we are asked to determine the initial rate when concentrations are something different than what was found in our three experiments. So the first thing that we'll do is look at the experimental values and see if there is something that is staying constant while the other one is changing, and take a ratio of rate laws for, in this case, experiments 1 and 2. We will see that the hydroxide concentration is staying constant, so it can be canceled. The K values cancel, and then we are left with 0.59156 being equal to 0.7692 raised to the x. It is not very obvious what x needs to be, so this is a case where we definitely have to take the log of both sides, rearrange the equation, solve for x, and then calculate our value. In this case, the order of the reaction in hydroxide is 2. Now we can choose two other experiments. I'll choose 2 and 3. It turns out that there is nothing staying constant in experiments 2 and 3, nor in 1 and 3, but because we already know the exponent for hydroxide concentration does not need to stay constant. We can plug in the value we have calculated, 2. The only thing that cancels then is our K values, and we will get a ratio of the rates being equal to 0.4402, this number right here being equal to 0.6602, and then we will have this ratio raised to the Y value. We can rearrange the equation, take the log of both sides, isolate our Y value, and get a Y value of 1. So now we know that the rate law is rate is equal to K multiplied by ClO2 to the second power and hydroxide to the first power. I could then choose any of the experiments to determine my K value. In this case, I will choose experiment 1, plug in the concentrations, the rates, the exponents, isolate K, and I get a K value of 230. Now, I need to remember that the overall order of the reaction is third order, so the units on my rate constant are going to be 1 over molarity squared times seconds. For part C, to determine the initial rate for an experiment that has ClO2 at 0.175 molar and hydroxide at 0.0844 molar, I simply need to plug in these concentrations, my K values, and my order, and solve for rate, remembering that rate always has units of concentration over time. The data that I've obtained to carry out these calculations are concentration and rates. So in order to do what we did, we need to know the rate of the reaction. We need some way to determine the rate of the reaction right at the beginning of the reaction.